Alright, this is an excellent handout to do in small groups, and I highly encourage you to run the lesson that way. You can start though by reminding the students that apparently from our last video, an irrational slope is going to end up filling up the whole screen, or at least seem like it is. And so the question here is, well, how many points does it hit? And so specifically, if we start off in that bottom corner, will it hit any other rational points? If you want to be more provocative, don't even hand out this handout. Just set the challenge initially. Say, here's my line, y equals mx. M is irrational. And maybe you can give m as some specific number, square root of 2 or what have you, and say, find me another rational point in this square that line is going to go through. And leave the students to try for a while. And when they start coming back to you saying, I don't think I can do this, I can't find it, it's not possible, say, ooh, you say it's not possible. Then, and only then, flip it around and then reveal the second question to them and say, hey, if you think it's not possible, maybe you can show me why it's not possible. And then let them wrestle with that. Again, great one to do in groups, have them wrestle together. As for the mathematics itself, it's not so bad. If instead of thinking about the line on the little square, we think about the line on the big plane, what does it mean to land on a point AB, where A and B are rational? Well, that means that somewhere out there, we land on a point that is A plus an integer and B plus an integer. And so what do we have? We have, say, let's call it little a and little b is the integer that way and the integer that way. And so we end up hitting a point a plus a, comma b plus b, where little a is an integer and little b is an integer and big A and big B are both fractions. Well, then both of those coordinates are going to be fractions. But if we hit a point up there where both of the coordinates are fractions and we start out down here at 0, 0, well, what slope does the line have? The line has slope b plus b over a plus a. And that's just a rational number. But wait a minute, we said we started out with an irrational slope line. So this is what we call a proof by contradiction. Or you could think of it the other way around. You could say, well, if we do go through some point, what kind of slope do we have? And now you've just shown that we have to have rational slope. So that means that we couldn't have shot with an irrational slope line. Let them wrestle with it. And if they're wrestling for a while and they're having trouble, maybe just suggest that instead of thinking about the little square, they start thinking about what the line on the big plane looks like and what going through a point A, comma B that's rational on the little square means on the big plane. All right, they should have fun with this one. Great group work.